Hi everyone! In our last video, we compiled and run our first C++ program called helloworld.cpp. It was a pretty basic program. It would just display to the user some text that said, hello CPSC 121. But learning that entire process of how to edit a source file, save a source file, compile and link a source file, and execute a source file is very important. We're going to use that over and over and over again this entire semester and beyond. So today I want to go back to that hello world example and go through it line by line and explain what each line means. And then I want to expand a little bit to make use of something called a variable. So let's take a look at the warm-up task for today. Go ahead and open a terminal, and in your CPSC 121 folder, create a file with gedit called basics fun. We're going to use it to describe all of the basics of a C++ program. So a C++ program has this general form. We're going to go through and type out the actual implementation for each one of these pieces of the general form. But if you ever are kind of like, oh, what comes first or what comes next, this would be really great to return to get that general form ingrained in your mind so that you can use it over and over and over again. So let's begin. The first part of all of our C++ files should be a comment. So it seems kind of strange, a comment. But it's kind of the idea that we can take notes in our C++ code so that whether we're the next programmer who looks at this code or some other programmer on our software engineering team is going to take a look and edit this code, they can read our notes via comments, and it will greatly help document the code for others to use. So a comment in C++ starts with 2 forward slashes. 2 forward slashes for a comment denotes a single line comment, which means if I press enter to go to the next line and start typing, notice that this code is not blue because it is actual C++ code. The compiler will try and compile. It's not a comment. If it was a comment, it would show up in blue. So that's one thing that you can look for in your code is syntax highlighting, which will change the color based on what gedit thinks you're trying to do. So we'll use comments a lot to take notes in our code about what it's doing. Here I'm going to make a comment to use as a note about comments. So comments are not compiled by the compiler. They are ignored, which means we can write English statements here. They don't have to adhere to C++ syntax. They can be anything we want, which is really, really nice. We can also have multi-line comments called comment blocks. So these start with /* and end with */. So anything in here is part of the comment. Notice that it's blue, just like with our single line comments, because all comments are the same essentially. It's just how we want to denote them when we start writing a comment. Is it going to be a single line or a multi-line comment? And a multi-line comment can be all on the same line. For example, a one-liner like this, that's totally fine. And you'll see some programmers prefer to do that instead of using the single line comment. So typically at the top of every single one of your programs, you'll have a big comment that says your name as the author of the program, what's the name of the program, what does it do, what are some assumptions of it, what's the date you last modified it, what are some known bugs, etc. Just a really good way to document your code for others to use. Now, after our single line comment, then we have libraries our program needs to include. So typically, we'll always include the IOStream library. So a library is denoted by its name surrounded by angle brackets, and it's precluded by include, #include, or #include, that says, hey compiler, we need to include these libraries. And the compiler will make sure that that library is linked to our code. So IOStream is for input-output streams, and we use it in order to gain access primarily to some objects called cin and cout. Now, we've already seen an example of cout. We saw it in Hello World. We use cout in order to display some text to the console. We can use cin in order to get text from the console, which would be something that the user of your program would type. Now, typically in the beginning, we are the users of our we are the users of our programs. So we're both the users and the programmers. But some other users of your program could be the grader, who's going to grade your programming assignments, your friends and family when you show off your programs, or if you build a program that you'd like to deploy for other people to use, then those people are also users of your program. Like right now, we are users of the terminal program and of the gedit program. All right, next comment. Any line that starts with a # is called a preprocessor directive. We won't talk too much about the preprocessor, but it is a smaller program or utility of the compiler that goes through and looks for all the lines that start with a # and resolve all of those dependencies, changing the source code as needed. We'll see a few more preprocessor directives later in the semester. After our preprocessor directives, we have using namespace statements. For us, with our small programs, using namespace is optional. We're going to use typically just one namespace, the standard namespace, which is what std is short for, so that we don't have to write std in front of a lot of common identifiers like cin and cout. In your future programming career or future programming classes, you'll learn more about namespaces and how they're used to resolve name conflicts. But like I said, for now, I would just get in the habit of always writing using namespace standard after your preprocessor directives, which are your #includes for your libraries. That way we can just use cin and cout directly without having to put all of these little characters in front of it. All right. Now we're kind of to the main event, which is the declaration of the main function. So every program has to have a main function. It is the main entry point to execution of your program. So when your program executes, it starts in main. It starts with the first executable statement and goes from top to bottom, executing one statement at a time. This is what the main function looks like. You'll want to also kind of get in the habit of just memorizing the syntax for the main function, just like we do for using namespace standard. We are going to learn a lot about why there's this word int here, main, open paren, close paren, curly brackets, etc. later in the semester when we learn how to write our own functions. So we will come back to this in more detail, but for now, we're going to kind of just take it for granted and use it until we kind of build up our vocabulary and our experience to learn about all the different parts of a function. So at the bottom of main, we'll have this line return 0, and this will always be the last line in our programs. And essentially what it does is says this program is done executing. And one more little piece of detail that I'll add here. 0 is the result code, and it tells the operating system, OS, this program executed successfully. And we define success as no errors. Nothing went wrong. So this is our basic template for kind of the minimum requirements in order to get to the point where we could save, compile, and test. And by test, I mean run our program and make sure that it's running for different types of input or different cases and things like that. So you'll want to get into this habit of save, compile, and test your program frequently. In fact, I'm going to write that on the board because it's so important. So it's kind of this loop, save, compile, test, save, compile, test. Do this frequently. You want to write a little tiny bit of code, save, compile, and test. Little tiny bit of code, save, compile, and test. That way, if there's a problem in your code, it's going to be much easier to find if you've only changed a little bit of it. So now we've got our main function coded up. Now would be a good time to head over to the terminal and try and compile this code. If you don't get any errors, then you can go ahead and run it. There's nothing this program does, so we won't see any output or anything, and that's okay. It's just a very bare bones program. If you did get an error, then you'll want to pause and look at the line number and try and figure out what's wrong and double check it. And just a little tip, if you're looking, for example, at my code, all of the blue are comments. So make sure that everything is blue that is not C++ code. So really there's only 5 or so lines of actual C++ code. Line 20, and you can make sure that the colors are matching mine. 27, 32, 35, and 38. All right. So we've kind of got the absolute basics of our program done. Now let's add in that cout statement that we had from Hello World and kind of dissect the different pieces of that cout statement. So it was cout. This is called the stream insertion operator, 2 less than signs. Hello. Let's do hello from basicsfun.cpp. All right, use cout to display text to the user via the terminal. And I'm going to say terminal is also known as console. Sometimes you'll hear me say console. Sometimes if you're online reading some things, or if you're in the textbook reading some things, you'll see console. That's just another name for terminal. So we can get console output using cout. In fact, that can help you remember what cout does. Console output, cout. The two less than signs is the stream insertion operator. It inserts whatever is to the right in the stream. We'll talk more about streams later. To the left, which in this case is cout. Now we're to this hello from basicsfun.cpp, which is in pink. The reason why this is in pink is because it is a string. Anything surrounded by double quotes is a string literal. And a definition for string, a sequence of characters. We will talk a lot about strings. A string is an example of a data type, and we'll talk briefly here about data types as well. Then we have another stream insertion operator, and then we have this Ndele. Ndele is a new line. And I'll show you an example of what a new line is here shortly. So remember, we are writing a little bit of code to save compiling and testing, write a little bit of code, save, compile, and test. So we've just written a little bit of code. Now would be a good time to save, compile, and test. So save, Control S is your shortcut. Compile, you can get from gedit to the terminal without taking your hands off the keyboard by using Alt-Tab or Option-Tab. Then compile, just use your command history, g++basicsfun.cpp, and command history to get your /a.out. And everything should work smoothly. So just to recap, Control S to save, Option Tab or Alt Tab to get from the terminal, from the gedit to the terminal, and then up arrow, command history to g++, up arrow a couple times to command history to /a.out. And you never have to put your hands on the mouse or take them off the keyboard. So you'll get really fast at doing this. Right now, everything is new and it probably seems really clunky and slow and like a struggle, but I can assure you, just give it probably only a week and you're going to be really fast at doing this because you're going to do it so much as you practice watching these videos, as we practice in class, and as you practice outside of class. Because that's the only way to get better at programming and learn this stuff is practice, practice, practice. All right. So we've gone through essentially every piece of our hello world.cpp file and described it using the most complicated terminology and details that we really can at this point. Some of this stuff you're going to have to just take my word for it. You need this here. This is kind of why. But as you start to expand your programming knowledge, you can come back and revisit some of these topics like namespaces and learn more about it. All right. The last thing I want to do in this video is talk about variables and data types. So I'm going to start taking some notes right under int main. A variable is a location in memory that stores a value. You already have some preconceived notion about what a variable is based on your background in math, in algebra, right? In algebra, you would use variables like x and y. Maybe you have y equals x squared plus 1, right? X is an independent variable and y is a dependent variable. You use this all the time. Well, we can have variables in programming as well. They're kind of like variables in algebra, except they actually correspond to a location in memory. So, for example, your RAM is allocated into little blocks called bytes. Bytes are based on bits, which are 0 and 1, on or off. And in each one of these bytes, you can store like a value. Like this, for example. Well, if you ever need to store a value to a location in memory, or you need to access a value, read a value from a location in memory, you've got to have some kind of way of labeling these. So your operating system will label these using hexadecimal addresses, way more complicated than we need for our purposes. So in a high-level programming language, we don't use numeric memory addresses to refer to individual bytes or cells or blocks of memory. We can, but we don't have to. We can use a nice English name like X, or radius for a circle, or size for a square, something like that, which makes it really, really nice for us to write code using those variable names. So maybe we call this location in memory X. We can read a value from X, and we can write a value to X. Now, one thing to note about variables and how they're different from perhaps what you learned about in algebra. In C++, we have to explicitly say what type of value will be stored at this memory location. It could be real numbers, maybe like you're used to from your experience working with algebra, or it could be integers, it could be characters, it could be strings, right? You've already learned a little bit about a string literal. A string is a data type. So we have a bunch of different data types that we can use in order to store values in memory. And we want to store values in memory so that we can save them, use them later, update them, read them, write them. So our definition for data type. A set of values plus a set of operations on those values. So some common data types would be int, which is short for integer. These take up 4 bytes in memory and can store whole integer numbers like -5, 10, 0, 1,000, 102, 7, etc. Whole numbers. We can also have float variables, which are used to store real numbers. And these typically take up 4 bytes in memory as well. These could be like 0.04, -9.0001, 3.14 for pi, etc. Real numbers. In addition to float, we also have double. And I'm going to write here, double stands for double precision floating point number. So a float is called single precision, double precision. The double part comes from the fact that it's usually twice as big. So this might take up 8 bytes in memory in order to store a double value. But same examples here. You could just be more precise. Like you could have more decimal places, for example, when working with a double instead of working with a float. In this class, we're not going to be writing any code that's going to use like highly precise computational algorithms. So you can pretty much use double or float. Just choose one and be consistent. I will typically just use doubles in my program because we're not short on memory. And it's just a nice habit to get into so that you don't have to worry so much about maybe not having enough room to store your number. So I would just probably stick with using doubles over using floats, but you should know about them both. Two more data types that we'll talk about now, and then we'll learn some other ones as the course goes on. So the next one is Char, which is short for character. So this usually takes up 1 byte in memory, is very small, and it can store things like single A, lowercase a, 1, not the number 1, but the character 1. We'll talk about this more later. Let's say tilde, exclamation mark, etc. Now, something to note about characters, and we will return to this in more detail, is characters have to be surrounded by single quotes in order to be characters. Remember, double quotes denotes a string literal, so single quotes denotes a char literal. Characters are actually stored as integers based on their ASCII codes. I just want to briefly introduce you to this. We'll return to it in more detail later. But just know that chars, single quotes, stored as integers, and those integers come from something called ASCII. Like I said, don't worry too much about this for now, but it's good to just get a little bit of exposure to it. And then the last one is string. And we actually already saw a definition for string, a sequence of characters. The size of the string depends on the number of characters in it. So I won't write a particular size for it here, but I'll just put some examples like hello. Note that they're in all caps. Or excuse me, note that they're in quotes. Sorry, they're in double quotes. And then, like for example here with 1, 2, 3, since it's surrounded by double quotes, this is the string 1, 2, 3, not the numeric type, like integer 1, 2, 3. Kind of tricky stuff, but we will go through it in more detail. This is just a nice introduction to what is a variable. Variable is a location in memory that stores a value. Well, that variable can only store certain values depending on the data type of the variable. And here are some example data types. Like integers are only storing the sets of values of whole numbers in a range that can fit in 4 bytes, for example. Integers have a set of operations that you can use to operate on them. For example, 5 plus 2 is 7, for example, but perhaps hello plus hi for strings is defined a little bit differently. So those operations depend on the data types of the operands. In order to learn a little bit more about data types and what are the ranges that can fit in 4 bytes, etc., you can take a look at the notes, or you can do a Google search, and it will tell you in C++ or many common programming languages what is the range of numbers for these different data types. Usually they're powers of 2. All right, so we are in basicsfun.cpp. It's time to declare a variable. So let's declare an integer variable called x. So first we specify the data type, which is int. Note that it shows up in this kind of bold green color. And then we have the name of our variable, x, and a semicolon. So this line of executable code here will allocate memory to store an integer in a location called x. Now, we could also initialize x to a value at the same time we declare it. Like here we could assign 5 to be stored in x. But those are two different things. So I'm going to keep them separate first. So declare an integer variable called x. Initialize x to store 5. So here we have x is assigned 5. So one thing that I'm going to work on retraining your brains is how to read code that has this assignment operator here. So the equal sign is the assignment operator, not the equality operator. There's actually a separate operator in C++ for comparing two values for equality. This is not it. This is assignment. And you'll want to get in the habit of reading this as x is assigned or x gets 5, because this is not expressing equivalence. For example, I could write a C++ statement that says this: x is assigned x plus 1. Now, your algebraic background tells you that x equals x plus 1. Well, that's not true, right? And that's because in programming realm, this is not equals, this is assignment, okay? It's like this location memory is going to take on the value of this location memory plus the integer literal 1. It's a little bit of a retraining of your brain, but we'll get a lot of practice with it. This is not equality, this is assignment. Not equality, this is assignment. So now I'm going to go ahead and print out x so we can see it. We use cout in order to display anything to the terminal, to the console. So I'll say x stores and then x. Then we see the output, x stores 5. Let's say I change this to 7. And I run it, and now it says x stores 7. Awesome. So I mentioned a little bit earlier that we would come back and talk about this Ndele and the new line. So here's our output currently, the way our code is written up. If I go ahead and take off this Ndele at the end, there's not going to be a new line that's going to separate the output from this cout statement and this cout statement. So I'll go ahead and do that so you can see. So before, each one of these cout statements output or text was on a different line, and now you can see they're all jammed and ran in together. So the Ndele is really nice for keeping your output organized so that you can easily find things. That also makes your user a lot happier if they can easily find things and read your program output and interact with it as well. Okay, let's see one more example of declaring a variable, and then we'll talk briefly about how to convert values between different data types, and then we'll call it good. So typically I like to put all of my variable declarations at the top of the main function. I think it just keeps it much cleaner, and also in some compilers this is actually required. So if you can get in the habit of doing this as well, that would be really nice. So I'll just make a comment and I'll say something like, good habit to put all variable declarations at the top of main so you can easily find them. If you start to kind of sprinkle these variable declarations throughout your code, it makes it much harder to read. So let's go ahead and do a double value, and let's call it, let's do it gas price. I'm going to initialize gas price to a value at the same time that I'm declaring it. So I'm going to set this, I think gas is, I think it's around like $3.89, something like that. And I'll just come down here and I will print out gas price. Awesome, that looks good. Okay, so let's say that we wanted gas price to be converted into an integer. Well, one way we could do this is declare another variable. I'll call it gas price as int, gas price as an integer. And I can initialize it to 0, or I can not initialize it. Typically, a good practice is always to initialize your variables, because if you don't initialize them, then essentially it's going to be whatever was previously stored at that location in memory. So here, I'll do a quick example of this because it's important. If I don't initialize gas price to a value, and then I go to print it out, I get this really weird value, which I call garbage values. Okay, so that's whatever was previously at this location in memory where gas price as int is interpreted as an integer, which is just nonsensical garbage. So always good practice to initialize your variables when you declare them. I'll leave this X and gas prices int uninitialized just for demonstration purposes, but good habit to always initialize them when you declare them, even if it's just to set them to 0, for example. Okay, so let's set gas price as int to be gas price. Now remember, gas price is a double. It has a fractional component to it, some value to the right of the decimal point. So what's going to happen when we store 3.89 in an integer? And remember, integers do not have fractional parts. They are whole numbers. So we get 3 printed out. So what happens actually is the fractional part is truncated. Which means it is chopped off. It is not rounded, it is chopped off. Now this happens as part of something called an implicit type conversion or implicit typecast that is performed when you assign a value that is of a higher precision to a location in memory of a lower precision. So a double has higher precision than an integer. But if we want, we could also, instead of doing the assignment, we could just print out gas price as an integer using static cast. So static cast allows us to specify the data type that we want to convert to. We put it in angle brackets, static cast int, and then gas price is the value we want to convert. So that's this output right here, just printing out gas price as an integer. So something to keep in mind is these different data types, when you assign them to variables of different data types, there's going to be some kind of casting that's going to occur so that, for example, you can force a double to be stored as an integer, or displayed as an integer, for example. Okay, so we covered a lot in this video. This is probably one of those videos that you might want to rewatch a couple times over again, follow along, take notes, and make sure that if you have questions, you bring them to class and ask them and let me know, because there's a lot going on here. And just keep practicing and you'll definitely get better at it, and these words, these terminology, vocab, etc. will sink in more. The last thing I'm going to say, and then I'll close the video, I know it's getting kind of long, is we talked a little bit about the syntax highlighting and how you can try to make sure that the colors make sense, like comments are blue, etc. Well, all of these different colors are based on the syntax rules for C++. So different programming languages have different syntax rules, so they'll be colored a little bit differently based on the rules of that programming language. Well, there are certain words that mean something about the structure of your program in C++, and these are called reserved words or reserved keywords, and they are reserved for use by C++ in order to define the structure of your program. For example, using namespace int double, include, and static cast and return. These are all examples of reserved words in C++. You cannot have a variable called return, because return is part of the C++ programming language, and you would get a compiler error if you tried to do that. Return is reserved for a certain meaning in the program. Same with static cast, double, int. You can't have a variable of type int called int. That would not compile. So keeping all this in mind, there is a lot to learn when it comes to the syntax, but you just keep practicing and keep reading the book and working through examples and taking notes, and it will all come together. For these variable names, we call these to be identifiers. So main is an identifier, STD is an identifier, gas price is an identifier. Those would be names in the code that are not reserved words that identify something. Variables are a great example of identifiers. There are some rules about how you can or cannot declare an identifier name. For example, you can't have variables that start with numbers, you can't have variables that have spaces in them, and you can't have variables that have special symbols other than an underscore. So you could not have, for example, an exclamation mark on the end here. That would not compile. So all of these rules we've kind of gone through at a high level, but in today's notes, there are details about each part of it that I highly encourage you to read. So like here's more about reserved words, standard identifiers. These are identifiers that are provided to us from C++, like cin and cout. You wouldn't want to name any variables cin or cout or main or standard, because that would cause problems in your code. But you could do it, but you wouldn't want to. Programmer defined identifiers, these would be like variables that you declare yourself. We did that a few times. There are different ways to denote the convention for declaring variables. Like here's a good example. If you have a variable like average score or gas price, for example, that have two words or two or more words, typically we'll use something called Camel Case, which the start of every word is capitalized except for the first word's first letter. And this is kind of the C++ Java convention to do this, but there's also Pascal Case, which is typically used in languages like Python, where words are separated by an underscore instead of with capitalization in Camel Case. And this is a good note that I'll read out loud. Do note that just like with the command line in Linux, the C++ is case sensitive. So if you have, let's say, average score with the S capitalized, and then you try to use it later in like a cout statement or an assignment statement where you have your capital S as a lowercase, you're going to get a compiler error unless you have also declared a variable called average score with a lowercase s. So here's some more information about variable declarations, data types. Earlier in the video, I recommended that you take a look at the notes or do a Google search to see the ranges of numbers that can be stored in data types like in double and float. So here's at least the range for the numbers that can be stored in 4 bytes, which is 4 times 8 bits, 8 bits per byte, 32 bits. And here's some more info about the data types. We'll cover bools here shortly when we start to talk about conditionals. And here's just a little bit more info about executable statements, assignment statements, and the assignment operator. In one of our next videos when we talk about arithmetic, we're going to come back to this idea of static casting and why it's really important, specifically because of something called integer division. But we'll return to that later. All right, so let's call that good. That was a lot of information. Definitely take a break, let that sink in, and return to the video if you want to get some more clarity on some things or bring in your questions, and I would be happy to answer them.